Hello, Algebra 2. Our next lesson is going to be evaluating expressions with rational exponents and to convert between radical form and rational exponent form. Before going through any of those notes, I really need to call attention to the word rational. Rational, if we look at that word, the first 5 letters are ratio. And a ratio is a comparison of two numbers with division. So if I were to take any two numbers and divide them, that would be a ratio. So if I did like 5 divided by 3, that's going to be a ratio. Or if I did 6 divided by 7, that's a ratio. If I did x divided by y, that's a ratio. So when we see things like rational exponents, we're really talking about fraction exponents. Remember how we did that review on fractions? Well, this is why we had to do it. Today, our exponents are going to be fractions. Oops. All right. On this next sentence, I'm going to show you a few things. We're going to look right here, here, here. So these are some expressions that are equivalent. The square root of a is equal to a, oops, sorry, that was supposed to be a pen, is equal to a to the 1/2 power. The square root of a is equal to a to the 1/2 power. It's a square root, but we never have to write the 2 here because it's like the most generic root, and we always know that that's the square root. But any other root, we have to write what kind of root it is. So this next one says the cube root of a is equal to a to the 1/3. And this third one says the fourth root of a is equal to a to the 1/4. And this works for any integer, for n, for any integer that is greater than 1. So if it's less than 1, it does not work. If it's 0, it does not work. It works for any integer greater than 1. So this says use a calculator to show that each statement is true. You should be able to type square root of 9 into the calculator, which hopefully you already know the answer is 3. And you should be able to type 9 to the 1/2 in the calculator. I'm going to go ahead and type that in so you can see me typing it in. But really, you can just try this on your own. You can speed fast this part if you already know how to type it in your calculator. So I'm going to type 9, and then I'm going to hit that caret button. And since I have the newer calculator, it makes the little box, but sometimes it just leaves the little caret in there. With my new calculator, I'm going to hit alpha y equals, and then that's going to give me the option of choosing a fraction. So while I'm in a fraction here, I'm going to put 1/2 and hit enter. We get 9 to the 1/2 is 3. So that is the exact same answer as the square root of 9, which is also 3. Now, that should be pretty easy to type in your calculator. It's the other, well, B should be fine to type in the calculator as well. It's maybe C and D that you might need me to explain. So, I'm sorry. I've had a tickle in my throat lately. It's my chronic cough that I've had in March, it'll be 4 years. And we still don't have an answer. All right, to find the cube root, under the math button, there's a lot of helpful things. In fact, number 4 is the cube root. So I'm going to just type 4, and it will give me the cube root, and I'm going to hit 8 and enter, and I get the number 2. And now I'm going to do 8, and then I'm going to put my caret. I'm going to do alpha y equals, enter to get my fraction. And I will go 1/3, enter, and I also get 2. So those are equivalent. And then we want to do, we want to do the 4th root of 16. So the 4th root of 16, I'm going to go under math. And then for this one, there isn't a 4th root, but you can do any root you want with choice 5. It's X. So we're going to hit 5, and you're going to have to put the number for that root, so 4th root, and then we go under the radical and we type in 16, and we hit enter, and then we're also going to do 16. We're going to do caret alpha y equals, enter, 1/4, and we get 2. So those work. If you have an older calculator, you might not be able to do this as easily. You might have to do 4 first, then do math, then choose the 5th option, and it will know that you want the 4th root. It's going to look different than mine. Oh, I wonder if I have a different form or different version. I think all of these are the newer ones. Anyway, if you have the 83, it won't put the 4 small, but you're still going to have to type in. I'm going to try that again. I'm going to do the exact same thing again. If you have the 83 model, which I don't think a lot of you in this class do, you would have to type in the 4 first, and then go to math, and then do 5, and then put your 16. And you can see it worked to do it that way, even with the newer calculator. So either way is fine. Okay, so I did all of those except for I didn't do the square root of 2. So I want you to check that one to see what both sides equal. Oh, and here's the directions of using the root. All right, to find an approximation for example, 4 to the 2/3. We're going to do 4 to the 2/3 in the calculator. Now, if you have the older calculator, or if you don't want to do alpha y equals, this is how you can type it in. You can do 4 caret parenthesis 2 divided by 3, or that's with the older calculators. Or if you want to do this on the newer calculator, you can. With the newer calculator, you can do 4 caret and then do alpha, then do y equals, then the enter, and then 2, and then you arrow down, and 3, and that will type it in as a fraction. I'm going to do it that way real fast. So I'm going to do 4 caret alpha y equals, enter, and then I'm going to do 2, I'm going to arrow down, and then I'm going to do 3. And we have a decimal. Rational exponents do not have to be in the form of 1 over a number. They can be more complicated fractions like 3/2, or they could be -1/2. So we could use all kinds of different fractions for these. When I was in high school, which was forever and ever and ever ago, my teacher always said that the power is on top because that's where power lines are. I better draw one more. I don't know. That looks kind of hard to tell. But power lines are up top. And then the number on the bottom is the root, because roots grow in the ground. So roots go in the bottom. And that's how I've always remembered it. Power lines and then roots. Now, the first example, x to the 1 over n is equal to the nth root of x. Well, that is because the n is the root. So that goes here. And that spot right there has a special vocabulary word. It is called the index number. And then here's an example where we've got, a number on top and bottom. The power will go on the variable on the base, and then the root goes on the radical. So let a to the 1 over n be an nth root of a, and let m be a positive integer. We can rewrite a to the m over n as a to the 1 over n to the m power, which we can rewrite as the nth root of a, that whole thing to the m power. And then we can also rewrite this as the nth root of a to the m. So these two are equivalent. And then if we have a negative, the first thing I'm going to do is take the base and it's m over n. It's a fraction. It's rational exponent to the denominator. And then we can separate out the m. We can change it to the nth root of a to the m power, as long as a is not equal to 0. Here's example with numbers in it. 8 to the 2/3 is equal to the cube root of 8 squared. So remember, this is root. They grow in the ground. This is power up top, like power lines. So we've got 8 to the power of 2, and we've got third root. We can also rewrite this as take the third root first and then square that answer. These are equivalent. And if you look at it, one of them may be easier than the other. For these, I think both of them are kind of the same, but sometimes we get harder ones that are easy in a different form. For this one here, we're going to start with that negative exponent first, and we're going to move everything down to the bottom. When we move it down to the bottom, it's equivalent to this, or it's equivalent to this. So we're going to evaluate each expression without using a calculator. And I can't stress this enough. You will have quizzes and tests with no calculator. Okay. So we're going to evaluate this. So what I'm going to do is I'm going to take this 16 and I'm going to rewrite it. And this top number is the power and the bottom number is the root. So I'm going to rewrite the root 16 and then we're going to put the power on. Now this is without a calculator, which would mean I would have to take 16 times 16 times 16 without a calculator. Or I can rewrite it as the square root of 16 and then that answer cubed. So you get to choose which one you want. I'm going to use the one on the right. If I take the square root of 16, that is 4 to the third power is 64, and I'm done. It's a lot easier than trying to take 16 times 16 times 16, and then take the square root of that without a calculator. 8 to the 2/3. We can rewrite that as the cube root of 8 squared, or we can rewrite it as the cube root of 8 squared. And then for this, I think either of these is about the same difficulty, but that's really kind of up to you which way you'd want to do it. If I squared the 8 first, I would get cube root of 64, which is 4. If I cube root the 8 first, that would be 2 times 2 times 2, which is 2, and then squared is 4. So either way, I get the same answer. You can decide which one you think is easier or, not. Let's see. This one you can't even type in the calculator. So this is definitely without the calculator. This would be the power over the root. So we've got the 4th root of y to the 1st, which is just the 4th root of y, and there's nothing else I can do. And that's it. And it does say to convert to radical form, so I converted it to square or radicals when I was done. All right, so we've got kind of 2 questions in D here. For this one, we've got the 5th root, and 3a is in parentheses, so that means 3a to the 1st goes on the inside, versus this one where only the a has the exponent on it. So this would be 3, and then it would be the 5th root of a to the 1st. Anything to the 1st power is itself. So this one would be the 5th root of 3a versus 3 multiplied by the 5th root of a. All right, here we have a negative exponent. So the first thing I'm going to do is just go 1 over 32 to the 3/5. Get rid of that negative exponent. Now it's positive. I can rewrite this as the 5th root of 32 to the 3rd, or I can rewrite that as the 5th root of 32 and then that to the 3rd power. So when I look at my 2 options, 32 to the 3rd is not something I want to do by hand. So I'm going to do the 5th root of 32 instead. The 5th root of 32 is 2. And 2 to the 3rd is 8. All right, and then question F is 32x to the 3/5. So this would be like 32 to the 3/5 and x to the 3/5. Both of them are to the 3/5. You could write that as the 5th root of 32x to the 3rd. We could write it as, oops, that was too big. We can write it as the 5th root of 32x, that whole thing to the 3rd. Or we could write it separately, where we look at the when we look at the 5th root of 32 to the 3rd multiplied by the 5th root of x to the 3rd. So I've just given us like a bunch of different ways of looking at this. It doesn't really matter which one you use. But I think actually I'm going to use this last one, but I'm going to tweak it just a teeny bit further. I'm going to do the 5th root of 32 cubed, and then I'm going to multiply that by the 5th root of x to the 3rd. So the 5th root of 32 is 2. And then I can't take a 5th root of x to the 3rd because there isn't 5 x's in there. So then I'm going to do 2 to the 3rd, which is 8. And then I can't do anything else with the x, so I just have the 5th root of x to the 3rd. And that's simplified. So now this is called student practice. This is where you pause the video, try on your own, and then check with the video. So 4 to the 5 halves, that's going to be power over root. So I'm going to have 4 to the 5th under a square root, or I'm going to have a square root of 4 to the 5th power. I look at my two options. I like the one on the right better because the square root of 4 is 2 to the 5th power is 32. 9 to the negative 1/2. First thing I'm going to do is put that 9 to the 1/2 on the bottom. Power over root, I'm going to get 1 over square root of 9, which is 1/3. And then 81 to the 3/4. Let's see. Power over root, we're going to have 81 to the 3rd. And then the 4th root of that, I can rewrite that as the 4th root of 81 cubed. And the 4th root of 81 is 3 to the 3rd, which is 27. Now, I have a different method of doing this one, which is coming up, which I think is even easier, but we'll see. You get to use which method you want to do. So example 2, parts A and B use a different method. So step 1 for this is we're going to factor the base. So this is a different method. We're going to do the exact same thing we were doing. This is actually the method that I think is, I don't know, the easiest, but that's really your own opinion when you try both methods. So we're going to do prime factors for 16. So 16 is like 4 and 4, which is 2 and 2 and 2 and 2. Okay, I could do that in my head. I'm just showing you prime factors. So we're going to rewrite 16 as 2 to the 4th power, and that is still to the 3/2. So all I did was substitute 16 for 2 to the 4th because they are equivalent. Then what we're going to do is we're going to use our power of a power property that says if I'm doing the power, I'm going to multiply the exponents. So I'm going to get 2, and let's see, to multiply these, I might want to put that 4 over 1. I'm going to multiply straight across, and I get 12 over 2. Well, 12 over 2 reduces, and I get 2 to the 6. So 2 to the 6th power is 64. Okay, question B. I'm going to start out by factoring 32. So 32 is 2 to the 5th. Okay, and now, and really, you can do this negative sign first or last. It doesn't matter. It doesn't matter if I flip it first and then do all of this, or if I do all this, then I flip it. It's not going to matter in the end. All right, I'm going to put the 5 over 1, and I'm going to multiply straight across. I get 2 to the 15 over 5, which negative 15 over 5. Maybe I should have flipped it first so I don't forget about the negative. So I get 2 to the negative 3, which is 1 over 2 to the 3rd, which is 1 over 8. I probably should have flipped it first because I almost forgot the negative sign. All right, 27 to the 1/3. I'm going to factor 27, which is 3 times 3 times 3. So 3 to the 3rd to the 1/3. I'm going to put this over 1. I'm going to multiply straight across. And I'm going to get 3 to the 3/3, which is 3 to the first, which is 3. And then 20 to the 1/2. I'm going to factor 20. This is a teeny bit different than the other ones. I'll write the 4 there for now. Okay, so 20 is not the same prime number over and over again. It's got 2 separate prime numbers. So at this point, I'm going to multiply each exponent by the power on the outside, and I will get 2, let's put that over 1, multiply straight across, to the 2 over 2, multiplied by 5 to the 1 over 2, which is 2 to the first, multiplied by 5 to the 1/2. The directions say to write this in radical form, so I'm going to change this back to a square root because it does not simplify any further. So 2 multiplied by square root of 5 would be the answer to that. Okay, and here we've got some, there's 2 examples that are similar to these up here, only we've got variables. And I really tried, I tried to move this, nope, that's not E, it would be G. I tried to move that example over, but for some reason it would not go. All right, example F, I'm going to use what we just did up there. Actually, it wouldn't be right above it. It would be from the first page. Sorry, we're going to change this into A, and we're going to do the power over the root. So we're going to do A to the 2/4. And then that does simplify to A to the 1/2. And then we're going to put it back in radical form. So I get the square root of A as my simplified answer. Question G, I'm going to do a similar way. We're going to have x to the power of 3 over the root of 12. And then we're going to have y to the power of 6 over the root of 12. All right, so I could do x to the 1/4, y to the 1/2. But those have different, they have different roots. So different. So that would tell me that I would have like the 4th root of x multiplied by the square root of y. I don't think that's very simple. I think more simple would be less square root or radicals. So maybe I'm going to reduce them down so they have the same root. Okay, I'm going to try it a different way. I'll just change my color. Different way now. Let's see. If this one has 3 and that one has 6, I could take out 3 powers from each of them. And I could rewrite it as x, y to the 2nd, and then that cubed. So now you can check my work. If I put it back in, I would get x to the 3rd. I would get y to the 6th. So that's equivalent. And then if I do it that way, I could do x, y squared to the power of 3 over 12, which becomes xy squared to the 1/4. And then we can rewrite all of that as a 4th root xy squared. So this is the easier way, I think, of doing it. This is not very simplified. Okay, the next is evaluating expressions using a calculator, and I was going over that earlier. So 9 to the 1/5. And we get about 1.5518. What does it say though? Round to 2 decimal places, so 1.55. And 2.539, that's going to round it to 2.54. And then the 4th root of 7 cubed. Well, we can type it in that way, or you could type it in as 7 to the power of 3/4. Either of those will work. Oops. There we go. Either of those works. 4.30. Remember, if it ends in a 0 and you're asked to do 2 decimal places, you need to write or type the 0. Okay, here's an enrichment example. We're getting close to the time where we're picking classes for next year, and enrichment would be those of you that are interested in getting through that college prep pre-calc course for next year. So a hospital purchases an ultrasound machine for $50,000. The hospital expects the usual life of the machine to be 10 years, at which time its value will have depreciated to $8,000. The hospital uses the declining balance method for depreciation, so the annual depreciation rate R in decimal form is given by this formula. R equals 1 minus S divided by C to the 1/n. In the formula, N is the useful life of the item in years, S is the salvage value in dollars, and C is the original cost in dollars. What annual depreciation rate did the hospital use? So we're going to be solving for R. So we're going to find R. 1 minus, now S is the salvage value, which up here is $8,000, divided by the original cost, which is $50,000, to the 1 over, and then N is the useful life, which is 10 years. Now, this would be a calculator question. You can type all of this into the calculator. I would not expect you would do that by hand, because I do not think I could do that by hand. Sorry, I'm trying to move my screen so I can see both of them at the same time. Okay. Well, all right. So 1 minus, now I'm going to do a parenthesis, alpha y equals enter. So I have a fraction. You can also just use division. 8,000 over 50,000, parenthesis. And I'm going to do a caret. Alpha y equals enter. 1 over 10. Now, this is a decimal value that is a rate. And our rates are like percentages. This is the decimal value. So 0.1674. Now, when we write that as a percentage, remember % means per 100. Oops, I got carried away. Percent means per 100 or for every 100. So we're going to take this and we're going to multiply it by 100. And we'll get a 16.74% depreciation rate. Okay, and then the last enrichment is find the radius of the figure with a given volume. Make sure you know the formula, the volume formula, and then for this one, and then you would you also need to know it for a sphere for, I think, a future assignment or extra credit. Okay, so the volume for the sphere is going to be the area of the circle. So pi r squared, that's the area of the circle, multiplied by the height. That's going to be our volume. So pi r squared multiplied by 9 has to equal 1332. Let's see, I need to divide both sides by 9. I have another calculator here I'm doing without switching my screen around. And I get 148. Now, we're going to divide both sides by pi. And I'm going to get r squared equals whatever 148 divided by pi is. That's going to be a terrible decimal. So to solve for r, we're going to square root both sides, which typically we need to do a plus minus, but our radius must be positive. So I'm not going to worry about the plus minus. I'm just going to find the actual positive answer. So this is what I'm going to type in my calculator. How about I type it in here? Square root. And then I've got a fraction. And it was 148 over pi. And we get approximately 6.86 for our radius. So I'm going to say the radius is exactly square root of 148 over pi, or it's approximately 6.86. And then we need to look at our units. And over here, our units are going to be centimeters. So which answer that you give, it depends on the directions. This doesn't say to round, so I would assume we do the exact answer. But if it said to round, we would do the approximate answer. Okay, that is it for this section. So go ahead and start your worksheet, lesson 5.